Hi, today we'll verify trig identities algebraically and graphically. Our first example is sine of x plus 3 pi over 2 equals negative cosine x. Well, clearly you could see this is a sum and difference identity. So in order to actually solve this problem, we're going to actually need to know our sum and difference identity. And I've written that out right here. Sine of x plus y equals sine x times cosine y plus cosine x times sine y. So, what we'll have to do is to make this part of the equation look something like this part. So we do this by simply following this example right here. Alright, so let's go ahead and expand this. So, this is simply sine of x times cosine of 3 pi over 2 plus cosine x times sine of 3 pi over 2. Okay, now if you look carefully at this problem, you see that this is a cosine of 3 pi over 2 and a sine of 3 pi over 2. Well, we know these two values. Cosine of 3 pi over 2 is 0, and sine of 3 pi over 2 is negative 1. So all we do now is simply plug in those values. Sine of x times 0 plus cosine x times negative 1. Well, you can see on this side of the equation, anything times 0 is 0. So this just simply cancels out. And cosine x times negative 1, well, that's negative cosine x. And look at that. That's how you know that this is a true trig identity. Now we will use the graphic technique to help us verify that cosine square x equals 1 minus sine square x is true. We'll do this by using a graphing calculator, which is highly recommended for doing this technique. So we'll just turn on the calculator, obviously, and I'm already, well, we'll press y equals, that's the first thing we do, and what we will do is plug this side of the equation into y1 and this side of the equation into y2. So let's go ahead and do that. Now we plug in y2, which is 1 minus sine x square. Now, all I'll do is press the graph button. And as you can see, it starts to make a wave-like pattern, which is what a cosine graph looks like. Well, you can see that there's no other line or any other graphs that are being formed, and this is because that cosine square x is definitely equal to 1 minus sine square x. They're following exactly on the same exact graph, and this can be proven by pressing looking at the table. So we'll press second, and then we'll look at table. And if you look at the table values, they're equal to each other. So 0.29193 is the same thing as 0.29193, which is y1 and y2. And you can see that those were the two equations that I plugged in y equals, look, cosine x squared, 1 minus sine x squared. So go back to graph, and you can see that these values are same throughout both sides, and that's how you know that these two are definitely equal and therefore an identity.